It's still good morning. Good morning, everybody. Welcome to this session. I know we are a bit, off the schedule at this point of time. Once again, for the folks who are standing at the back, there are rooms on the either side of this room where this entire session will be streamed live. Make yourself comfortable. There are additional seats available. Okay. For those who follow cricket, Sri Lanka is faring very badly, 127 for 8 at 36 overs. So South Africa will go past their choker stack hopefully this time around. Okay. Just wanted to ensure so that people are not worrying about what's happening on the ground there. Okay. So with that, we'll get started. And the session is about building multi-tier applications or solutions using cloud services. Okay. Myself, I'm Puneet Shah. I work as a Premier Field Engineer with Microsoft. Been working with premier customers of Microsoft with their code reviews, server health checks, production optimization, and primarily on Azure since last couple of years and things like that. And with me, I have Samiksha, who's going to help us with all the demos. Samiksha, over to you.
Hello everyone, good morning. My name is Samiksha Khare and I'm a technology evangelist. I work out of Mumbai and the primary technology that I focus on is Windows Phone, Windows 8 and Microsoft Azure. Me and my team were responsible of adoption of Microsoft products and technologies at the grassroots level, and it's a job that I really like, and I prepared this demo for you all. Hopefully you'll enjoy our session.
Cool, thank you Samiksha. Let's move forward. Okay, so what are we going to cover in this session? Okay, we'll see, we'll start with the normal service, how Azure comes into picture, how do you take it to cloud, and how do you integrate various other features that cloud provides you as part of your application development platform as such. Okay, so you would have heard terms in terms of like when you move to cloud, you can move to something called as IaaS, or you can move to something called as PaaS, or something that you can move to Azure websites. Okay, there are multiple options to take your web application workload or server-side workload to Microsoft Azure. So how do you decide which one is the best? Okay, so you can choose as a platform. I wouldn't say one is better than the other or one is worse than the other. You have multiple options, each has their own pros and cons, and depending on what exactly are your requirements, you'll decide on the platform for deployment of your services. So what do we have? Infrastructure as a service, which is basically more suited for your lift and shift kind of applications. These are basically the VMs that you host on Microsoft data centers. Okay, you manage their patches, you manage their service packs, you manage your application configuration and all of it. You own that particular VM that is running in the cloud. On the platform as a service aspect, you have two options. Okay, one is either you can host it using Azure websites or you can host it using Azure cloud services. Websites is more suitable for scenarios where you just want to publish your web app without additional configurations or fine tuning or any environmental setup that you need or dependencies that you want to set up, the easiest of all of them all. Okay, and then you have cloud services, which is the focus of this session, where we will talk about how do you go about building multi-tier solutions on Azure cloud platform as such. So if you want to compare in the contrast, and if you want to think in terms of what features they really differentiate on all these three hosting platforms that are provided by Azure, we'll talk about websites, cloud services and virtual machines. When it talks about control, website doesn't give you too much of control to play around because all of it is taken care of by Microsoft or the service provider. Okay, you just have to worry about your application, your data, you push it to the Azure services, and the service provider, in this case Microsoft, will take care of hosting it, configuring it, making it available on internet and guaranteeing you that high availability of 99.9% availability. Cloud services pretty much on the similar line, but you get a little bit of more control about how do you want to configure your IaaS when you are deploying your application. You want to install some additional dependencies as part of your application deployment is what you will get with this. Whereas with virtual machines, you pretty much own everything. You can go ahead, configure, install, do whatever you want to. It's your VM that is running. The only thing that the service provider or Microsoft is taking care of in this case is giving you the hosting infrastructure. Okay, when you talk about legacy app support, again websites support it to an extent, whereas with the cloud services you'll get more flexibility about hosting your legacy applications. With VM you can pretty much do anything at all. You can even configure a VM and host your VB6 Windows Form application, will work fine. It is your OS and your system that is hosted in the cloud. Ease of management, the easiest them as I mentioned is websites, because there's hardly that you need to take care of except for your application and the code. Cloud services, there are a few things which we will cover as we progress through the sessions that you need to take care of as a developer or as a person developing solution to be deployed on Microsoft Azure. With VMs, that is infrastructure as a service, it's pretty much everything that you own as responsibility except for managing the physical infrastructure. OS versions, patches, service packs, your application patches, all of it, it is your responsibility at the end of the day. Okay. And then in terms of agility, since you don't need to monitor or configure or have the ownership of too many things, websites has been the most agile of all of these three options available to you. And then the cloud services and the VM. In VM, you own the responsibility. So coming back to the question, which platform would you choose to host? So if you were to ask me that particular question, what is the right? I'll say it is websites. Until it is not. Until you figure out something that Azure websites cannot do, then I'll say it is cloud services. Until it is not, until you figure out something that you cannot do with cloud services, then it falls back to infrastructure as a service VM. It is not that IaaS is bad, it is just that being a developer, you shouldn't own up all that responsibilities of, managing, configuring your VMs and things like that. Okay, so with that, we'll start with our first demo. What are we going to do is, Samiksha is going to walk us through an application which is currently on premise, okay, and then she is going to explain what this application does, and then we'll continue forward with the session. Over to you, Samiksha.
Right. On the screen you can see there's a website, Microsoft Azure Guestbook. It's a very simple one-page website where you can put your name, you can put any message, you can upload any picture. For example, you're just walking around the corridor and you like something and you want to do that. So you just hit this URL, you put your name, message and picture and click on submit. Right now if I try to put my name and a message, and let me browse any picture, any random picture, and click on the submit button, the button is giving me a pop-up message. That's because currently the image is not getting stored anywhere in the backend. It's just a one-page website. It's a website, it's running locally. You can see the URL, it's running locally. Over the course of next few demos, I will show you how to take this website, which is currently running locally with no storage at the backend, to cloud completely. So this is the introduction to our website. Over to you, Puneet.
Thanks. Can switch. Okay. So what are we going to do with this application? So over the course of this session and this demo, what are we going to do is we will integrate this with our cloud project. We will start using some of the cloud services. We will make sure we are able to debug, test this locally, and eventually at the end of this, we will deploy this entire solution on Microsoft Azure. So essentially, what we are doing is taking an on-premise application, modifying it to an extent where we start leveraging all Azure features and deploying it on Microsoft Azure. And eventually we'll end the session where we will ensure that we also take care of additional capabilities provided by Azure in terms of how do you scale, the elasticity factor, how you can increase the number of instances, decrease the number of instances, and how you go about configuring those things on Microsoft Azure. Okay. So you've heard the term cloud service a lot during Q&A, even when reading other stuff all around on the web, webcast and things like that. So what exactly is the cloud service? Cloud service is basically a concept where you focus on your application. You don't need to worry about where it is going to get hosted, how it is going to get hosted and things like that. You basically worry about your application and your data, okay? And the platform, in this case Microsoft Azure, will provide you with all the capabilities for your solution, which includes availability, scalability, reliability and things like that. On top of that, monitoring and diagnostics. We will look into all of this as we progress through the session. So what is cloud service? It is essentially a container of a service roles. There are two types of roles that Azure provides you. One is worker role, another one is web role. So a cloud service, when you want to deploy your application to cloud, you basically have to provision something called as a cloud service. Cloud service is a container of all these roles that are part of your application or the solution. And what do these roles do? This is where your actual code resides. So when we talk about web roles, it is nothing but a pre-configured Windows server which has IIS pre-installed. So anything that you run on premise on IIS you can configure it to run as part of your web role as such. Default firewall ports for HTTP traffic and things like that, and any IIS workloads. And it's not limited to .NET platform as such, pretty much any IIS workload, PHP or other stuff that you can run on premise with custom CGI extensions, you can pretty much enable the same things on the Microsoft Azure web role also. Worker role, differs a bit from the web role in the sense it is pure vanilla copy of your Windows server and it does not have IIS installed, or for that matter anything else installed. If you were to correlate it with your on-premise workloads, your web role is like your IIS server, your worker role is somewhat like your Windows services that you write. Okay, you'll write your code which will run on a schedule, keep on checking either a queue or something else, or you can pretty much run any third-party executable that you want to host, or for that matter, it also gives you capability in terms like you want to run your own executable, and run an Apache server on this and configure it as a web server. You can pretty much do this. That's not what is indented for, but you can pretty much do any of your custom code running on your worker roles. Okay. What can Azure run in terms of web roles or worker roles? A simple rule applies. Anything that runs on Microsoft Windows, it will run on Windows Azure, or rather Microsoft Azure. Choice of language, we're no more limited to .NET. You can choose your framework, your language, and will be able to host it successfully, running seamlessly on your Azure platform. Be it .NET, Rails, Zen, all of this, all the support is provided out of the box. There's no too much of an effort on your end to just get these things configured on your cloud services when you want to deploy as such. Okay. So what is basically essentially a cloud service? Coming back to the same question. So you take your application, your data and things like that, you bring it all together. Azure will provide you all the resources to host that application in the cloud. Okay. Once this partnership goes on, okay, successfully, what you can do is now you can take care of all the additional Azure features like, automation. You want a version deployment. You don't want to deploy something to the production, but a staging environment. Azure gives you that capability. You want a continuous deployment from your TFS instance. Every time you check in a code and things like that, you want to get deployed in a continuous manner, either to your staging or a production slot. Azure gives you all those capabilities. That way, how does it help you? It reduces the overall cycle time for each cycle of your revision of the application that you're pushing it to Azure, things like that. You get enough feedback quickly enough, get you good insights into how your application is performing, and good, speed to market. Essentially, you don't have to wait for a day or two to get things rolling and stuff like that. Happens within few minutes. Gets you good agility, insights, continuous improvements over a period of time, and eventually what that results in is the total cost of ownership going down over a period of time. And let's not forget the key things that a cloud platform provides you in terms of availability, reliability, and the most important that I really love about it is elasticity. Scale as much as you want and scale back, as much as you want without you having to take care of physically provisioning servers or anything of that sort. So when you try to take things in a different perspective, I'm just trying to concentrate on the cloud services again and again to explain it from all different perspectives. We've seen logically what it means, we've seen what it can do, and now we will see how it basically works. So cloud service is nothing but when you register or create a cloud service namespace, you get a URL associated with you, with your namespace. It can be cloud service name, your name.cloudapp.net, typically suffixed by cloudapp.net. And then has a load balancer built in, has firewall capabilities built in. Even when you create an infrastructure as a service VM, you still have to create a cloud service because cloud service is the global container under which you provision all your resources. So you get a URL for that. Even for virtual machines, if you were to provision in a cloud service, you will basically open up a instance input endpoint. Typically, like if you're hosting a SQL on a VM that you provisioned as part of your infrastructure as a service VM, you'll open up port 1433. Similarly, you have something called as web roles. You can have a single instance or a multi-instance web roles, which by default have port 80 opened as we saw in the earlier slides. And then traffic can be routed directly through firewall, through load balancer across all the instances that you're using to host your application on Microsoft Azure. You also have something called as worker roles, which we discussed earlier. Worker roles do not have anything open by default. Okay. So if you want to open up, let's say you want to run your service and host your WCF service in that and make it open to public directly, you can explicitly go ahead and open those endpoints. Let's say you want to run it on port 8081 or something of that sort. It also has a concept called as internal endpoint. Let's say you're hosting some proprietary service on your worker role and you do not want your external world to talk to it. You only want your internal services that you hosted in cloud to be able to communicate with that particular worker role. That capability is also provided by specifying something called as internal endpoint. So you can create those internal endpoints, and only your other services which are deployed as part of your cloud services, they will be able to communicate with those worker role. Okay, that's by default. Worker roles will not have anything open to public out of the box. Of course, you can have the capability, but that's not what typically worker roles are intended for. That's what where your code resides. For data, you have Azure storage where you can use various factors, services provided by Azure storage. You can integrate with Azure SQL database, which is again a SQL PaaS capabilities given by Azure platform as such, and lot of other cool stuff as we saw in the previous slides. Your Azure Active Directory, media services, ACS, too many things, multi-factor authentication and all of that, which you can seamlessly integrate with your application as part of your PaaS. So when you talk about roles and instances, what are roles? Roles is basically nothing but a template. Okay. At runtime, what you do is when you tell Azure, I want to deploy this role, Azure will ask how many instances do you want to create out of this. That also what you specify in your code, and then Azure will take that template where you specify what your VM size is, how many VMs do you need, how much CPU or RAM do you need, and the Azure Fabric Controller will create those VMs. If it is a web role, we'll install IIS, we'll take your application, configure a website in that IIS, deploy it, make sure everything works, and get it, put those servers in a load balancer for your users to be able to access your application. At runtime, what basically happens is you basically take this role template and create instances, pretty much like your class and object kind of comparison. Your role is like a class and your instances are like your runtime objects, which you create an instance at runtime. Okay, so you have a template where you specify which OS do you want, which VM size do you want. VM sizes will give you in terms of RAM, CPU and things like that, and then whether it's a web role or a worker role and stuff like that, what endpoints you want to expose. And at runtime, what happens is you start creating instances out of this particular role definition. Okay, and to guarantee you an SLA of 99.95% of uptime, we typically recommend you should have minimum of 2 instances for each role that is deployed as part of your application. Okay, so this is just an illustration of a single cloud service with one web role, one worker role, where your web role has around like 8 instances and your worker role has around 6 instances. These are dedicated VMs that Azure Fabric Controller creates and provisions for your application to run in the cloud as such. Cool. So with that, we'll move back to Samiksha, where what is she going to do next is take that on-premise application, start integrating cloud services into that. Okay, over to you, Samiksha.
Thank you, Puneet. So in the last demo, what we had seen was we had an application, and on the click of the submit button, there was a pop-up message. In this demo, let's make some changes to it. Before we get on to that, I would like to introduce the 5 Azure components that we will be using in this demo. Number 1, web role, worker role, blob storage, queues, and table storage. Puneet, would you like to give one-liners for a
Sure. So Azure, as we saw in the cloud services, we have 2 roles, web roles, worker roles. Web roles typically suited for your web type of applications. Worker role typically suited for your background running processes, image processing, video processing and things like that. Similarly, Azure Storage also provides you 4 different form of services. One is blob, which you typically use for storing anything, any binary large object, video, audio, images, documents, reports, whatever you want to kind of stuff. Then you have tables, which are not like your SQL table because this is NoSQL. It's a name value entity which you can store almost anything that is available to you. An entity can go up to 1 MB size and stuff like that. Then you have queues, because we don't have MSMQ in the cloud, we have something called as storage queues, where you can push messages which can be retrieved by worker role for background processing and things like that. And one of the other features which is available in preview is called as Azure Files, which is pretty much like your network shares that you can mount onto your cloud services. As long as your share and your VM or the instance is provisioned in the same data center, you can just mount them as a network share and typically use all your system.io operations or namespaces, whatever you want to implement in your code, they'll work seamlessly.
Right. Thank you, Puneet. Okay, before I jump on to Visual Studio, let me briefly tell you what changes we are going to make. So in the previous demo, on the button click message was popping up. In this, what we are trying to do is, on the click of button, the web role is going to push the URL of the image into the blob, make a entry of that, make the entry of whatever you have, the name, the message and the photo into the table, push a message into the queue. Then the worker role is going to monitor the queue, fetch the queue message, parse the message, make some image processing done, update the blob, update the table, and there's a timer in the web role, and in the timer, when the timer expires, it will reload with the updated image. This is what we are trying to do. So number one step, we have our website. Imagine we just have a website. Number one thing we have to do is connect this website to the database. How do we do that? By using connection strings, right? And so in our project, what we are going to do is that, first let me tell you how to create a cloud project. So I would say open file, new project. Give it a second while it's loading. And if you have downloaded the Microsoft Azure SDK, which is what templates is what you'll get out of it, you'll see a template called Azure Cloud Storage Services. You can change the name over here, change the name of the location of the solution and solution name, and click on OK. Once you do that, another wizard is going to pop up, which is going to ask you, do you want a web role? Do you want a worker role? Which kind of web role? Which kind of worker role? You can start with only web role, you can start with only worker role, or you can create a project which has both web roles and worker roles. Use these arrow buttons to select the web role and the worker role. Over here, you can see an edit button. You can customize the name that you want to give it and click on OK, and your project will be ready. For now, I don't want to do that because I already have my own project. Just give me 1 second. I'm going to open my project right over here. Here. So this is how your project is going to look like. There's one cloud project right over here. There's one web role project, which is your front end. You can write your website or whatever GUI you want to have for your solution. And one worker role project, which is relatively a simpler project, and you can write your background process right over here. We have an extra project for our guestbook application, which is guestbook_data. This is for the data IO operation. We have made it as a separate project because we want both web role and worker role to access it, and we wanted to avoid repetition of the code. So let's get back to our step number 1, connecting your Visual Studio project to the cloud storage. To retrieve the database connection string, you can go to your storage. Creation is very simple. I'm sure you must all know. Click on this new button and then quick create. And write your URL for your storage, define the area, whether you want it locally redundant, geo-redundant, and click on create storage. I'll not create it because I already have created it. So these are few of the storages that I have. If I want to connect my Visual Studio project with this storage account, here is what at the bottom you see manage access keys. You will get the storage account and the primary key right from over here. Now we'll go back to Visual Studio. And in our cloud project, whichever role I want to connect first, the web role or the worker role, I can click on the configuration file. There is a configuration file which uses XML, or there's this beautiful graphical editor that you can use for the same purpose. So if I'm going to use the configuration file, here are few configuration files that I'm going to use to define my data connection string. And I can take the name of my storage account. Here is the storage account name. This one. Here, storage account name and the key, account key from the portal. Just copy the account name and the key from the portal and put it here. The better option is to use this graphical interface. Click on setting, which is the second option. Add a setting, define the data connection string, and using this ellipsis which comes over here, manually enter the account name and account key, and you are set. As simple as this, your Azure project is connected with the database. Second thing that you have to do is, on the click of the submit button from our website, few things should happen. The changes should happen. Let's take a look at what's happening on the on click of the button. So let me open the code behind the on click. Here's the code. Sign button click. So the first thing that is happening is uploading the image to the blob. Second thing that is happening is creating a new entry in the table. And the third thing that is happening is put a message in the queue. This is what is happening in our web role. let's take a moment and see what the worker role is doing. So worker role has one class called workerrole.cs. Before we move on to that, one more quick thing that I would like to point out over here is that workerrole.cs class is inheriting from the base class role entry point. And if I go back to my web role and open the webrole.cs class, it is also inheriting from the same class role entry point. If we go to its definition, we will see that there are three methods in role entry point, which is onStart, onStop, and run method. These three you can override both in web role and the worker role. OnStart method is the method where you will put the code if you want to set up the environment in the virtual machine in the Azure data center. So basically, once you are deploying the service in the Azure data center, the Fabric controller is going to read your code, and whatever you have asked, while it is spinning the virtual machine for you, is going to do it for you. OnRun is the method where you actually write the code for the execution. For web role, it doesn't make much sense because IIS is already running it. So see, you have not overridden, you have not mentioned any code in the run method because IIS is running it. But that doesn't mean that you cannot override it. You can definitely do that. But in the worker role, the whole point of worker role is to put a code in the run method because that's where your execution code is going to happen. So if I show you what our worker role is made up of, you can see there is onRun method that it has written. Then there's onStart and onStop, and there's a process image. Process image is the method which is actually taking, so once you upload the image in the web role, the worker role is going to take that image, compress that image into a thumbnail, and then update the blob and the table and the queue, and hence your web role will be updated. This is the image processing that is happening in the process image method. On the run method, if you will see, it is starting with retrieving a message from the queue. The web role is going to read the message from the queue. It will parse the message from the queue. It will call the process image method, then upload the blob, upload the table, and they'll remove the message from the queue. This is the simple things that our web role and worker role are doing. Do you want to see the application running now? Let's try to hit F5 and see how our application look like. In this solution, as you know, I've already connected it with my storage account and I've already mentioned all the code. Right now, if you can see, the roles are taking the help of the Azure emulator, which means that still your application is running locally. It's still not deployed in the cloud, and on the basis of the emulator, you can still run and test your code. I think that's a very good opportunity for developers to not even have an Azure subscription, and using the emulator, you can debug, you can test your code and develop the applications. So here is what our application looks like now. So now if I were to enter a name, or let's say, and a message, and if I have to take up an image and hit the submit button, the image is over here. And you can see the URL, it is localhost. But what we have done so far is that although our application is running locally, it is using the Azure storage, the blobs and the tables in the queue to do its job. So now that I've uploaded the image, and you can see the image has become a thumbnail, which means during the time I was speaking to you and the image was uploaded, it did all the work that I described before, and the worker role has uploaded it. Let me take you to the Visual Studio and show you the image which is now present in the blob. So this is the Server Explorer right over here, which you can use to check out your update or check out your blobs and queues. So my Azure account or the storage account is this one, AZ Conference. If I go to blobs, blob has my guestbook pics container. Open it, open the folder. Here are all the images which are there. If I open the image, it's downloading, and this is what I had uploaded. So which means from the web role, the image is now present in my blob storage. And if I see this thumb URL, you can see that the thumbnail is also present, which means that the web role put the image in the blob, then thumbnail also, the worker role also put the image in the blob. Second thing that had happened was our table. Table had made an entry. So if I open the guestbook entry table, you can see Shelly, which is the latest entry that I had made, which means that my web role has pushed the message over here. So now in this demo, what we had seen is how to take your on-premise website, connect it to the Azure cloud storage, and use it to do your job. Over to you, Puneet.
Thanks. Okay. So anybody copied her connection string key? That would have been a very good opportunity. Never share this with anybody, even with the demo. So what are the typical worker role patterns that you use this for? Okay. This is pretty much, I would say, if you are a developer who's worked on Windows services, you can pretty much relate to it very closely, okay. Queue polling worker, that's what we've seen. Worker role keeps on monitoring a queue, any additional message, you go ahead and process it. It can be listening worker role. You host your own WCF service, open up on certain port and listen for incoming messages on a given protocol, on a given port and things like that. Or if you have, let's say in this case, we had a, what do you say, a code that was processing the image. What if you had some other third party executable that you want to run that will generate different encoded files out of a video file that you've uploaded and stuff like that? You can start those external processes also using the worker roles that you want to implement as such. From a web patterns, I think it's pretty much your IIS workload running in the cloud. You can host your ASP.NET 3.5, SP1 onwards, anything at all. Host your web form, what do you say, web form application, MVC application, all that stuff, even fast CGI applications that runs on IIS platform as such. You can host multiple websites as part of your single, what do you say, web role as well. Can run on HTTP, HTTPS, can have your own custom certificates deployed as part of your cloud service and all of this. By default, the OS that gets provisioned, as of now, when you deploy your cloud service, it will be a Windows Server 2012 image with IIS 8 running as such. Okay. So the next question is, now that our application is ready, we were using Azure services, but we were running and debugging everything locally. Next is we want to deploy to Azure. How do you choose what is the best VM size? Azure gives you lot many options, but always remember, bigger is not always better. You can get a 16 CPU machine and 56 GB of RAM to host your web application, which is just like a guest book. It may not work out financially for you. We'll be happy to host your applications with as many instances as you want, pay per minute kind of stuff. So do not just throw very large VMs at any workloads. Test for different configurations. Figure out your key performance indexes and where those benchmarks are met. Some scenarios like video processing and things like that, having multiple cores may help you, but not in all the scenarios as such. So test for different configuration, figure out where your KPIs are being met, your benchmarks are being met, and then decide how many instances do you want for resiliency and things like that, and then decide what is the right VM size for your application. So with that, we'll move back to Samiksha, and what are we going to do now here is package this entire stuff, put it into Microsoft Azure Cloud and see things running in the cloud, which will be a live URL which you can use for next 2 days to click pictures, put in your message and things like that, and we'll see everything in action. Okay, right. Over to you.
Thanks, Puneet. Very important when you're creating a package. There are a couple of ways you can upload your application into Azure Cloud Service. You can make a package and deploy it at the portal. You can use a PowerShell command, or you can directly publish it from Visual Studio. What we are going to do in this demo is make a package and then upload it into the portal. So if you're making a package and uploading, where do you define what is the size of your VM, or how many instances do you need? There has to be some provision for you to do that. Now, 3 very important files for that in that reference is these: service configuration file for cloud, service configuration file for local, and service definition file, which are a part of the cloud project. So if I open the service configuration file, where if you remember we had also defined the data connection string, right over here you are defining the instance count for web role, and right below it for worker role you are defining the instance count. So for example, I am just a blog writer and this is just a website or a web role and a worker role for my blogs. I don't think I require 3-4 instances. I can just do 2 instances or 2 instances. But let's say I am a good company and I have this solution which I have to deploy. 2 is definitely going to be less for you. You might need 4 to 5 instances as per your solution sophistication. So this is where in the service configuration file you define the number of instances. Now size of the VM. So in service definition file you can see that there is a VM size right over here. Here you can define the VM size, small, large, extra large, whatever the size VM comes in. Also one more thing, you can, like I showed you, there's a graphical editor for everything. You can do the same thing using the graphical editor. Just double click on the web role and into the configuration tab, you can define the instance count and the size of the virtual machine that you want to use. Right? After all this, what?
Just quick question. When we said 2 and 2 here, so total 4 VM?
Correct. Right. Yes. Total 4 VM.
Remember, to guarantee you the SLA of 99.95%, you need to deploy minimum of 2 instances. Right. Okay. That's the case for cloud services, not for websites.
Right. So now we have done with all the formalities and everything is in place. Now only thing that remains is making a package and uploading. To make a package, right click on your cloud project and click on package. When you click on package and you start creating a package, your package creation will start. And meanwhile, let's navigate to our portal and see if there is a cloud service ready to take this package. So to do that, we'll go to the cloud services. It's very simple to create cloud service. Click on new cloud service, quick create or custom create, mention your URL, mention your region, and create cloud services, and within 3 seconds your cloud service will be done. So in my case, I've already have a cloud service which is running. So let's say this is the cloud service. In the dashboard, if you click on dashboard, there is 2 slots, production and staging. You can directly deploy your application or upload the package to production, or you can do that for staging. I have already deployed the application in staging, so let me try it for production. So here is the upload sign right at the bottom. Click on that, and there are 2 ways you can upload your package, from local or from storage. And you can see there are 2 slots. One is package and one is configuration. Now, if you go back to Visual Studio, and you will see our package is already created. And I can see this jumping, which means our package is created. You can see there are 2 files when the package is created. The same, the service package file and the cloud service configuration file. Copy the path from here and paste it into our portal and upload the file over here. If, however, you're using one instance, although you will not get the SLA, but you can do that if you wish, and you just have to check this box that I'm using one instance. But it's always advisable that you start with at least 2 instances. Upload, give a label, and click on OK. So let me actually do that for you. Actually, can we skip, because we are running out of time? We have to show the auto scale demo.
No. So what we're going to do is this package, it's anyways deployment takes around 5 to 7 minutes, because what Azure Fabric will do is go ahead, figure out what do you need, it will create those VMs, it will install IIS, it will copy your code and things like that. As a backup, what we've done is we already have this deployed in the staging environment. Okay, so she'll browse the staging URL right now, and then we'll do something called as VIP swap.
Okay.
Okay, which will make your staging the production, and which will make your production environment the staging, and we will get the same URL to browse this.
Right.
Okay.
So since I've deployed it on the staging already, this is my cloud service, and if I browse down, on the right hand side you can see a site URL. Let me click on that site URL and see what happens. Our whole application is appearing here. Now if you see the URL.
Just a moment. Another thing you may want to note to confirm is, in the earlier demo we were running locally, we uploaded this image. This is running in the cloud, we still see those things. Just to ensure that when we were running locally, we were still using Azure storage services and storing everything in the cloud, which is what is available now.
And now our application is running totally on the cloud, and it didn't even take me like half an hour to do that. I did it right in front of you. So that's how easy, simple and fast all of this is. Now if you'd like, you can enter your name, you can enter your message and submit, and your application will be here. So if you now, let me quickly take a moment and take you to this next cloud service, where also I have deployed the same project, again on the staging. If you want to move your staging to your production, if you see there's nothing in the production right now, you can just use this swap button. You click on that button and your staging, it will ask you of course to confirm, and your staging deployment will go to production. And if you're not happy, I think you can swap back. I think that's an option too, right?
Yes. So what you can do is, typically you deployed a new version, you want to test out, you figure out things are working fine, you swap the environments, your production becomes staging, staging becomes production. All of a sudden people start reporting issue, you swap it again, you move back your new code to the staging environment, your earlier version to your production environment. Okay?
He has a question.
Yep.
Can we have both environments running parallel?
Yes, absolutely. You pay for both environments. Okay.
Can we have more than 2, like if there's a rigorous CD, continuous deployment process, you have a SIT staging.
Cloud services gives you 2 deployment slots. Websites gives you up to 5 deployment slots.
Possible to roll back to any previous version? Not there.
Have the packages ready, deploy those packages. Not from here. They are at the most 2 copies, that's all, staging and production. Can we take questions later? We just need to cover a few more stuff. We have a dedicated Q&A sessions, and I'll be available post the session also for Q&A. Okay, I know we lost our time earlier in the day. Can we move back to presentation? Okay, now we've taken our on-premise application, moved it to the cloud. Now let's look at some of the other scenarios what Azure provides you in terms of feature. One of the stuff is redundancy. Anything you use with Azure storage, we have 3 replicas maintained at any given point of time. You don't pay for 3 replicas, but that's the SLA that we guarantee. And what you can also enable is geo replication, which means it will be replicated across multiple data centers also. Okay, so for a application, for your service to go down, it does not mean it has gone down completely. It may be a temporary glitch, but if you try again, you will be able to access the resource, because there are 3 copies maintained at any given point of time, which is why we say in your application, when you're moving to cloud, implement try, catch, retry pattern. Okay. Then you have Azure SQL database that also maintains at any given point of time 3 copies of your databases. Okay. With websites and cloud services, there are multiple instances we recommend to deploy, and at any given point of time, one instance goes down, Azure will automatically spawn up a new VM, get your code deployed, put it back in the load balancer without any manual intervention whatsoever required. Okay. Azure Fabric keeps on monitoring this stuff, and it will take care of all those things. When you're working with infrastructure as a service VMs, you need to create something called as load balanced sets, which is what you will achieve this with. The same thing where anything goes down, the Fabric controller will take care of bringing it up back online without your intervention as such. Okay. Now, reliability, auto recovery, as we discussed, for anything that goes down, Azure will automatically bring it online either at the same place, or it says it's not able to bring that up, it will bring that up in another server rack or some other location in the same data center and stuff like that, put it back in the load balancer. We have a concept called as fault domains and upgrade domains. Important to understand these 2 things. Whenever you deploy 2 instances, Azure ensures it does not deploy in the same fault domain, which means a group of resources that are expected to fail together. Let's say you put 2 instances on the server rack and the power goes off, your both instances will go down. What we will ensure is when you deploy 2 instances, they are across fault domains. So the probability of both of them going down is together at the same time is very, very negligible. Okay. Upgrade domains, similarly, when you are upgrading a deployment, we also ensure that not all your instances are upgraded at the same time, thereby making your service unavailable. We have a concept called as upgrade domains, and all the instances that you deploy, they are spread across upgrade domains, and then each upgrade domain is updated with the new version of your code one at a time, so that your service remains available even during the time of update. Okay. VIP swap is what we saw in the action here. In this case, the upgrade domain doesn't come into picture. You deploy to a different slot, test out everything, and you swap the environment. If you're not happy, something goes wrong, you swap it back. Ideally, once things are stable in the production environment, delete everything from staging, because that's a meter running on a continuous basis. Okay. Cool. Scaling, you can scale up, increase the number of instances after deployment as well. Okay. Scale out, that is the increasing the number of instances. Scale up, which means you can increase the size of the VM. For that, you will have to redeploy your application. You cannot do it directly as such. Okay. Then you can use CDN, so that all the resources, images that you're browsing need not hit your storage account every time. If let's say you deployed in Southeast Asia, somebody browsing from US, with CDN, this can be cached globally across multiple servers that are geographically close to the user who's browsing this application. And then the typical caching pattern, which we recommend even for a standard on-premise application development, so that you don't hit database again and again, or any resource that that will involve transactions, you don't want to do that, you can use caching, that is also available. So scale up anytime, now that we've developed a Facebook kind of application, which is guestbook, which is going to go, usage wise very, very high over a period of time, we want to scale it out. What you can do is simply add more instances. You don't have to redeploy your code. You just say increase the number of instances, and Azure will take care of creating the VM, installing IIS, copying your code, creating a website, put it in load balancer, and you're good to go. Over a period of time, you decide people are no more having, instead of Facebook, it turned out to be Orkut kind of application. You can reduce the number of instances as well, go back to your standard 2 instances, that you want to let it run on. So this was just an off instance, but typically for your app, let's say performance review applications, during certain times of years, usage will be high. Financial applications, every month and quarter end, the usage will be high. Then it goes down to normal and things like that. You can play around with this. All these instances you pay per minute. So it's not like you provisioned and you pay for this entire month. For whatever minutes those number of instances were running, you pay for that. Key thing to remember here is all these instances that you create are stateless. I repeat, stateless. I repeat one more time, they are stateless. Okay. If you've not heard me, I repeat one more time, they are stateless. The reason I am saying so is, anytime you use IO calls to store something on C drive locally on the VM where your application is running, for whatever reason, if that VM crashes, Azure will just bring it up at any other place. There's no guarantee everything that you've stored on your local disk will be available to you at any given point of time. Those states are not maintained, which is why we recommend use of storage services. Don't store anything on your local VM because these are stateless as such. Azure can bring them up at any point of time. I repeat for the last time, these are stateless VMs.
What about session information? They are taken care of.
The next slide. Embrace stateless and you will love platform as a service. As long as your application is stateless, you can scale to hundreds of instances, scale back and things like that. To address your question, ASP.NET application, you want to use session state and stuff like that. The features available, you'll have to use custom session state providers, which will in the backend use either the Azure Cache service or the Azure Storage service or anything of that sort. But remember, this request between multiple instances, you don't really want to keep them sticky session. You're not making good use of the infrastructure that are available, which is why, embrace stateless in your application, and PaaS is really the platform for you. Scale as much as you want. You can achieve all those objectives. There are APIs available, custom extensions available, everything will work. It's not like it won't work, but as long as you are stateless, that's the last time I'm saying that word, you will love PaaS. Okay. So, moving that, we'll now see the cloud service that we have deployed shall help us scale out. We will scale the web role, we will scale the worker role, increase the number of instances, and you will see it in action without any downtime. The URL is still accessible, and instead of 2 instances on the web role that was running, we will now have it running on 4 instances.
Right.
Over to you.
Right. So in the first demo we had on-premise, second demo we added Azure Cloud Storage, third demo we took the whole application and deployed to cloud service. Now it's time for fourth demo where we will see scaling. To scale your cloud service, choose your cloud service from over here and navigate to the scale tab. Once you do that, you will see the current summary of your web role and worker role. Remember how we had 2 for each, we had defined the instance count into the configuration file. That's where we are at this moment. If I scroll down, the first half of the page gives me guestbook underscore web role and couple of ways by which I can scale. I can scale by time or a schedule, I can scale by a metric, I can define the number of instances that I want for a particular role. If I scroll a little bit more down, I can see guestbook underscore worker role and a couple of sets of things that I can do to scale the worker role. So let's say here's my web role and I have two instances given, but I'm assuming that my application will do really good and I want at least, 7 to 8 instances to scale up and down when needed. So I'll move the slider and I'll define the number of instances that I want to choose. Once I can also scale by metric, I can choose CPU and I'll get another sets of sliders where I can define what kind of configuration I want for my scale by CPU metric. The first slider again asks you to define the number of instances up to which I can go. And Azure will not go above or beyond that. Whatever you will define over here is where you will be. So again, I will take it to 7. Then the second slider is about the target CPU. This slider will ask you to set a range. Set a range of CPU consumption where your each instance will run at any given point of time. For example, let's say I have three instances running and I have 4 more at where I can scale as and when needed. So what Azure is going to do is that it will monitor the CPU consumption of your running instances. If in any case one of the CPU consumption is getting beyond 80, which is more than 77, which is more than what I have defined, it will get another instance ready. It will again keep monitoring it, and let's say at some point of time your CPU consumption goes less than 51, which is what I have defined, it will take down an instance. So this is where you define the consumption usage, or use this slider to define the consumption usage.
So basically 2 modes of scaling here. One is you can automate this based on runtime observations of how application is behaving and stuff like that. It will take care of scaling. Another one is manually. Can we see manually in action where you just increase the web role instances?
Yes. And save.
Okay. Once you do this, now if you go to instances tab, what it is doing is your URL is still accessible, and what it is going to do here is it is going to spawn additional VMs. Okay.
It might take time though.
Yep.
So hence you will have to check out that 5-minute
Post.
thing.
Yep.
Yeah.
So once we cover a couple of additional slides, we'll come back to this same page and we will see our more instances are running. But anyways, trust me, it takes less time than you would do it on premise creating 4 VMs with IIS and your applications deployed. Okay, not more than few minutes here. Cool. Can we switch to the slides once? Yep. We registered 7 instances. Azure will start sending you alerts. Then probably you need to change your VM size, redeploy, or create additional instances and things like that. By default, Portal gives you these options, but if you expect hundreds of instances, you can call up Microsoft support and tell for my cloud service, give me hundreds of instances. I want to scale to. Scaling will take few minutes. So by the time I complete 3 more slides, you'll have this running.
Minimum 5 minutes if
Okay.
if you're looking at some number that you want. So when you were in the CPU tab, I'll show it to you again.
Okay,
There is a
slide.
minimum time that you can set up and minimum number of instances that you want Azure to spin up at one given point of time. If you set this as 1 and the minimum time 5, every 5 minutes, if your solution requires additional instances, it will come. And if you set this to 3, at one time 3 instances will be added if required.
Yes. Charged. Okay. Per minute. Cool. So with that, we'll see the scaling actually resulting into the action as such. What are the other recommended sessions for the day? If you are from the app services stack and things like that, you can go ahead and try for dev and test on Azure, which will be not exactly at this time, probably now, 15-20 minutes. We're going to cut short the lunch break as such. There's another one is building IoT in the I don't remember the room here, but probably here itself. And then you'll have highly scalable web applications on Azure. Some of the recommended sessions if you are from the app services track as such. We also run a webinar series called as Azure Vidyapit, which are free webinars on various Azure topics that goes on, throughout the time frame. It's not like limited to anything. Feel free to attend those, register for these things, and you'll be, getting insights into various Azure services and stuff like that. Okay. We've had few Q&As. Myself and Samiksha will be available outside this room for next 20 minutes for additional Q&As and stuff like that. By the time this thing gets, scaling happens here, I'll just take 1 or 2 more questions here in the class. And then for those who've attended who have the apps downloaded, you can use that to provide the feedback for the sessions. We really appreciate so that we can, plan accordingly for any other sessions as such. Okay. So this is the QR code. You can scan this or you can give the feedback directly through the app if you've already downloaded. And with that, I think we'll say it. I'll take a couple of more questions, and I think few goodies for the people who asked questions. I think you asked few ones. You asked one. I'm short of time. Sure. Feel free. Tell me.
Yeah. So is it possible for staging environment to save cost? Can we share worker? Can we put worker and web role both on one VM or something?
No. Web and worker role will always be on 2 VMs. You can have 2 websites on a single web role. Okay. Yep. One. I'll be available outside. Yep. It's short on time. Come outside and we'll show that in action.
Yeah.